Hello, everybody. How's everybody doing today? Let me open up the chat here in a different window so I can see if anybody has any questions. Hello, Darsh. How are you? Hey, Adrian. Welcome. So today we're going to talk about Node.js and Docker, some best practices. So one of the best places to start, let me switch over here to sharing. So one of the best places to start with best practices for any language that you're going to be that you're working with is in our docs. So we have a great best practices file in docs. So go to docs. There's the URL right there. Let me drop this into the chat. So that is a great resource for best practices for Docker files just in general. So we're going to talk about, hey everybody, good to see everybody. Cool. So yeah, so here in the Docker docs, we have a best practices document that really walks through a lot of the best practices you want to think about as you're building out your Docker files. So today I wanted to talk specifically about Node, but a lot of the things that we're going to talk about today are general to all your Docker files. So one of the first things, so we go, okay. So just reading the chat. Hello, everybody. Glad to see everybody. It's just me today. Chad is not able to make it today, but he will definitely be back next week. Next week, we're going to be moving to Thursday. Same time, just on Thursdays. All right. So one of the main things you want to think about in general about your images is they're ephemeral. When I say ephemeral, meaning they could be short-lived and they can die and then you can restart them without a lot of configuration and setup, right? You want these images to be able to run, and if something happens, they died, another one can fire up and start running, right? So so a lot of things we're going to talk about is kind of in that context. You want to have your images be stateless. So the next thing you really want to think about is what processes you want to run inside of your image. The best practice is you want to just have one process running inside of your image. So before I came to Docker and I was just starting to learn Docker, we were building an application for an insurance company here in the Texas area. And we had a couple different processes running for this application. A couple background processes. They were node processes that would just spin up every 5 minutes. They would read a queue in, do some processing, and then go to sleep. And then they'd wake up back up, read some messages in the queue, do some processing, and go to sleep. And the way we used to run that before we started running things in containers is we would have just an EC2 instance. We had a couple of them. And we had an Nginx load balancer in front of it that would send traffic. And then each one of those EC2 instances, we had a second node process that ran this background process, a couple of them actually. And they would fire up, they would each look in the queue, and they would pull messages off the queue until the queue was drained, and then they would go to sleep. And so when we started first thinking about Docker, we were still in this mindset of virtual machines. And we created an image, and we created all of those processes inside of that image. So we actually had a couple processes running inside that image. And the reason you don't want to do that is if one of those processes running inside that image dies, you could kill your whole container. Your whole container can fail and stop running. And that would happen to us very often, right? Until we kind of really understood what an image was, and an image is just a wrapper around a process. And you only want to be running one process again. And so we ended up splitting out our processes into multiple images and ran them in multiple containers. So you really want to think about just running one process inside of your image. And If that process dies, then you're able to start that image back up inside of a container and run it again. And you can have multiples of those containers running at once. That's why you want to keep them stateless. So in a web application, if a request comes into your load balancer and it goes to container A, it runs, returns its response, and then the response comes back in. The load balancer might send that to container C. And if you were saving state in A before that on that initial request, when that second request goes to container C, it's not going to have that state information. So you want to make sure you keep all of your state outside of your images, and you want to keep them ephemeral. Think of them as short-lived. They can die at any moment, and you can just start them back up. There's a little bit of a best practice around security too. Is you can do rolling restarts of your containers. So at the insurance company, we had our containers running, and we had, I think, about 5 of them. And at about 2 a.m., we would bring each one down and start up a new one. And that was in case any of our containers were compromised. If a hacker somehow got inside of that container was stopped and would kick everybody out, and a new one would start back up. That's not shouldn't be your first line of security by any means, right? If someone is getting into your container, you got bigger problems than worrying about exactly what's in that container. How did they get past your network through your virtual networking system and into an actual container is a bigger issue. So let's jump into, so that's kind of just a framework that I wanted to kind of set. And hello, everybody. Everybody's jumping on. Good to see everybody. A lot of names and faces in the images. A lot of you don't put pictures in your avatar. No avatar pictures, but that's okay. It's good to see a lot of names. If you have any questions as I'm going through this, go ahead and drop them into the chat here. But okay, so let me get my notes. Let me situate my notes a little bit better so I can read them and see the chat at the same time. My second monitor is not that big. I need to get a bigger second monitor. Okay, so one of the first things you want to start with when you're thinking about your images is, what's your base image? So a base image is a image that's already been built for you and has a lot of tools, libraries, and has been configured to be a base image. So Node has a lot of base images. So let's take a look at nodes. So if you go into Node.js, Docker images, let's go there. And we should end up on Hub real quick. Let me sign in. Everybody close your eyes. Don't look at my password, my dots. Okay. So this is the official image for Node on hub.docker.com. And as you can see here, we see a bunch of tags. Let me explain what a tag is. So you have the format of your image. Let's see, a best might be now. Okay. So what you don't want to do is do this, just a Docker pull node generally. So the way we name our images is we have a namespace or a repository. In this case, it's node. And then you have a colon, and then you have a tag. So if you do just a Docker pull node, the default tag is latest. So it will just pull the latest. Whatever was the last image that got pushed usually becomes your latest. And the problem with that is, if we have at the top of our Docker file, man, speaking this morning is hard. So if we're just pulling latest from Node, latest can change underneath you. And so one day you might be building your image using Node latest, and everything works fine. 2 days later, a week later, this usually happens. It happens when you least expect it. Everything is running fine, your images are running fine, and then all of a sudden they stop working, and you haven't changed much, and you can't figure out why. A lot of times is you're pulling the base image of latest, and latest has changed underneath you. Some of the dependencies have changed that's not working with your package JSON. So what we want to do is make sure we give it a specific tag. So in this case that you're looking at here on the screen, let me make sure this is big enough. So we're looking at Node 12.18.4, and that's the latest. Let's go here to Node.js.org. And you can see here that's the LTS, the long-term support is 12.18.4. So now if we come back to the tags, the way you want to read these tags is when you're looking at images, you'll usually see they'll list out a bunch of tags, and then as you read down through, it'll explain these image variants and how they work. So you see here we have node and then the version number, and you can read about it here. And this is saying right here, this is the de facto image. And then they have a -slim and a -alpine, and you can read about these here. The -slim work really well. I use those a lot. Okay, so this kind of describes what the images are, and then as you scroll back up, we can see all of our 14.11, and then we have our 12.18.4. And if you look back at the Node website, you see 14 is the latest, is the most current, but it's not, it can change. It's not the long-term support. So you also want to match up what you're developing locally on your development machine and what you're building in your Docker images. So if you're using 14 locally to develop in, you're going to want to use 14 as your node image. But basically, you want to make sure you pull a specific tag and just don't pull latest. I won't get into what's the best base image to use. A little bit of that is subjective. It really depends on your needs. But generally speaking, you want to get the slimmest base image that works for you. So when I say slim, I mean the image size is as small as possible, and it has removed all the tools, extra tools, libraries, things you don't need. So like text editors, those type of things. You don't need those in your production builds. And that way too, if anybody does ever get in, a hacker ever does get into your container, they don't have a lot of the normal tools to use to attack your image. The surface area, attack surface, is a lot smaller. Uh-oh, I spelled something wrong. Not sure what, but let me know if we'll see if something breaks if I haven't spelled it correctly. But what is Alpine? And Adrian there, yeah, generally speaking, it's a lightweight image built on the Alpine project. There's a lot of Docker images that are Alpine. You'll hear that a lot, and they're very slim images, and they're based on the Alpine distribution. Okay, so again, make sure you give a specific tag of an image that you want to use. And I like to start out with, when you're first creating your Docker images, especially if you're new to Docker, don't worry too much at first about getting the smallest, slimmest image possible. You first want to get your application running inside of the image and running correctly. And the best way to do that in this case is to use one of the fatter images. So we're going to use Node 12.18.4. That way you have the exact kind of install that you are working with developing. If you're developing on 12.18.4 and then your image is based off of 12.18.4, that gives you that removes the inconsistencies between what you're developing with and what you're running with. So it's a good practice to kind of start with that. After you get it running, then you can try out the slimmer images and see if things break, see if there's a package you might need to, library, a package you need to add into it. But start out with just getting it working, and then optimize for size. Okay. Another thing too, as we're looking at the Docker file here, you wanna make sure your commands in your Docker file are in the order that is best for caching of layers. And what I mean by that is each one of these Docker commands creates a layer inside of your image. And don't worry too much about layers, but they're read-only layers, and they get layered on top of each other, right? And the big thing you should think about is they're cached. Each one of those layers is cached. So as Docker is executing your build, it reads in from top to bottom, just like you would execute JavaScript. And so it reads in from and says, okay, the from keyword tells Docker, this is the image I want you to start with. Okay, so it'll pull that image down and it'll start that as your base of your image, and then everything gets layered on top of it. And so as we work down, we set a working directory. This is a shortcut that all subsequent commands will then work against. So when we do a copy here, instead of me saying this and then copy into code package.json, since I set my working directory above that, I'm already sitting in that code directory, so I don't need to do that. And so it slims down your Docker files, makes them a little bit more easier to read. And then later on, if you want to move this into app instead of code, you don't have to go down everywhere in your Docker file and change it. So, okay, back to caching. So as Docker reads down, it creates these layers and then it caches them. And so if we run this the first time, we'll pull in the base image of Node, we'll set our working directory, then we'll copy in the package JSON locally on my machine into the image, into the code folder. And then it'll copy the package lock JSON in, right? And then it'll run npm ci -- production. So that'll actually run the install for npm. So it'll pull down all your packages and install them into your node modules directory. So once that happens, and then down here in line 10, we're going to copy in our source code. And we're going to copy everything in that current context, Docker context that we're working in, and copy that into the code directory inside of our image. And then down here, we execute our node. We start up our server. So as we're walking down through here, package JSON gets copied, package lock, we install, and then we copy our source in. So now we start working, we change some source code, we've updated some things, and we rerun our build. So when Docker comes back in, it says, okay, start at node 12.18.4. I have that locally. I don't need to go ahead and pull that again. We set up a working directory. That's fine. It will look at this layer. This command creates a layer and a hash, and I won't get into how it does does a cache hit or a cache miss. But it'll look, has anything changed in this package JSON file? If things have changed, it'll go ahead and run that command. It'll copy that package JSON in again. If nothing's changed, it just uses the cache. It just goes to the next line. Again, we would have nothing changed. So now it gets down here and says, oh, well, nothing's changed, so I don't need to install anything. So it uses the cache there. And then it sees you change the source code file. It'll copy that source code file into the image, and then it'll run your command. So that's really all. That's how your caching works. You want to have the files that you change the most often as far down in your Docker file as possible. So in this scenario, if we're changing a lot of source code and we're rerunning images every time we change some source code, this is okay here as I have it on line 10 because it's at the bottom right before my command. And that's the only thing that will cause the cache to be deleted and rebuilt. But if this copy command was up here, every time I change source code, every layer below your cache when it gets deleted will be rebuilt. So in this case, if I just changed one letter in one of my JS files and saved it and redid a Docker build, the copy command would be, that cache would be invalidated, and then every cache below it, so on line 7, 8, 10, would all be invalidated, and everything would run again on each build because we've changed a little JS file and it's above all the other layers. So all those layers get deleted and they get rebuilt. So if your Docker builds are taking a long time, that's one of the first areas you want to look at and make sure that your files that most often change are at the bottom of your Docker files, far down in your Docker files as possible. Okay. Let me see some questions here. Let's see. So how can we set the container to run for a certain amount of time and then close the container when the time limit crosses? Is there any configuration required in the YAML? Not really. Your container is started and it will stop when the process inside of that container ends. Then that container will end, will go away. If you want to do something like that, if you have a long running process and you only want it to run for a certain amount of time, you can bake that into your source code for one. So you can have a timer in your source code, only let it, and then your process takes care of how long it is to run. But if you need to handle that outside of that container, it would be the same as if you were running a process locally on your machine in the terminal and you only want it to run, let's say, for a minute. You'd have to time that somehow and then kill that process. Same thing with your container. Something outside of that needs to watch when it is started, do a timer on it, and then cancel it. Be interested to hear more what's the problem you're trying to solve with that, because there might be some different ways to think about it. Can you tell me what npm CI -- production is? So yeah, so it's basically, I think it stands for continuous integration. What that does is a clean build for you. And let's just jump into the documentation, npm CI. So it does a clean slate. Sorry, talking's hard for me this afternoon for some reason. So if you want to go to this npm description and read all about it. So it's used a lot in these automated environments, such as your continuous integration and your deployments. It'll be a lot faster. It won't user-oriented features. Yeah, so you can. I like to do it in all my production image builds. It'll just make your image a lot smaller. If you have a development Docker file, I wouldn't use CI. I would just do an npm install or an npm I. Because you want that npm install to be the exact same as you're working in your dev environment. Yeah, Adrian, that's correct. I don't want to go too deep down that rabbit hole, but yeah, if you search the differences between CI and install, it'll tell you the differences. There's probably some good blog posts on it. If you can't find anything, tweet at me and maybe I'll write a blog post, go a little more in depth on it. Okay. So we talked about caching. We talked about using a specific tag. Don't use just the latest tag. You want to use a specific tag. You want to start with the version of Node that you're using to work with as you develop. Get your application running inside that container first, and then look at changing to use a slimmer version, a smaller base image, so you can get your images smaller. And then you want to make sure you put the commands in order, where the files that change the most you want to have at the bottom of that Docker file, so your caches don't get invalidated and your builds will be faster. And then also there's another file called Docker ignore. And so what Docker ignores works just like the git ignore. So we can do a get status. Anything in your git ignore is ignored. Git says, okay, what your git ignore tells Git that I don't care about these files locally. Don't track them. Don't worry about them. I'm not going to put them into the repo. Docker ignore is kind of similar. When you do a Docker build and you give it a context, so let's jump over to command line here real quick. Where are we at here? Yeah. Okay, so if we were going to build this project, I'd do a Docker build, I'd give it a tag, and let's just call it server. And I'm just going to call it 1.0. And now here, when I give a dot, what that dot is representing is I'm passing to Docker a build context, a context that I want Docker to use. And a context is telling Docker, this is where all my files are located. This is where I want you to work inside of as you do the build. And inside of that, we're not giving it a file name. So we're not telling it what the Docker file is, because by default, Docker will look for the Docker file. We'll look for the Docker file named Docker file. So that's why you see a lot of times, you'll see a lot of demos, a lot of blogs, tutorials, those type of things won't specify the actual Docker file, because it is named Dockerfile. So here I'm giving it a dot, and I'm saying work in this local context. And so when it runs, it'll Docker bundles that all up and passes all those files into the engine, so it'll use to build. And what your .docker ignore file does says, don't pull these files out of the context and send it to the engine. I don't need them to build. I'm not going to use them. Don't put them inside of my engine. And so that's why here I'm able to say I don't need to do .js files, copy all those over. I'm not specifically naming files that I need to be copied into the image. You can absolutely do that if you only want, like if I only wanted my server.js file to be copied in, I could just specifically tell it, just copy that file and not everything else. So anything you do not want to have in included in the context, put it in your Docker ignore. That, although it's in your context, doesn't necessarily mean it'll end up in the image, because you have to move it in there and you have to copy it into it. But it also reduces the amount of files that will be sent into the Docker engine before you build. Yeah, it looks like you guys are just talking about alpines. Yeah, base images are interesting. So we could probably do a whole talk on base images. Yeah, I think Brett, I don't know. Someone check with Brett. He might have changed from the alpine tag, but maybe not. So anyways, okay, so that's your Docker ignore. It will tell Docker to ignore these files in the context. Don't include them in the build. Don't send them to the engine. We don't care. We don't need them. So things like your license file, your README, log files, those type of things, and your .env files. So, you could be working locally and you have .env files that you're using with NodeMon or something like that. And you might have passwords in there, database passwords, username and passwords, secrets, any kind of secrets. Sometimes we put in our environment variables. That's a longer discussion. I wouldn't use environment variables for secrets anymore. There's some better options around with Buildx and BuildKit. You can use secrets. In swarm mode, you can use secrets. But so you make sure you have a Docker ignore, and at the very least ignore your node modules file. You don't want all of this stuff to be copied, because in our Docker file, we're going to run this, and that will stay inside of your image and put only the node modules that you need. All right. So he either prefers Alpine or Slim. Yeah, Cole. I can't remember what his. I'll have to ask him. I'll ask him. He stays pretty up to date with that. And if anybody, if you want to, feel free in the chat if you have opinions around Alpine or Slim. I would love to hear them. Okay, so I might come. Let's see where do I want to go with. Okay, so let's talk about multi-stage builds. So even though JavaScript is not compiled, it's still a good thought to do multi-stage builds. So I'm going to switch over to the UI. This is just a React application, and we're using Node, of course, because it's JavaScript, to do our build. But with React, React is not run on the server, it's run in the browser, right? So we don't need a very big, huge, full node process to be running, because it's not going to execute any of our JavaScript on the server. All we need is a nice, quick, fast web server to serve up our static files, to serve up our static JS, possibly CSS files, right? And so here in the Docker file for the UI, I have a multi-stage build. And what multi-stage builds allows you to do is a couple different things. One of the big things is you can label your froms, your images. So you'll see at the top, I'm still using Node 12.18.4, but I label it as build, right? So in this scenario, I'm going to do a build phase, And by build in this scenario, I want to pull down my npm packages, and then I'm going to do an npm run build. That build, so inside of the npm, you'll see a script here that's build, and that's going to run the React scripts build. And that's going to, I believe it uses Webpack, and it's going to take everything, put it all together, put it in one JS file. It's probably going to do chunking and those type of things. And then it's going to minify it and make that JS file small, and I can never say this word, obfuscated, I think. We'll go with that. But make it not very easily to read. So it might change your big, long function name from get password from user and encrypt to that function name that's really long. It'll change it to A, right? Or it'll change it to A1. And so when you ever look at a minified, obfuscated JavaScript file, it's really hard to read. All the variable names have been changed, all the function names have been changed, the classes have been changed. But so the React scripts will do that and some other things. Packages it all up and puts that into your build directory, dist directory, I'm sorry. So if we come back here, let me double click this so it stays up. So that's what this is doing here. It's saying, okay, install the npm packages, copy my source code in, and then run this React scripts build. And then that will put everything into the build directory. And so this is one image right there. So that creates an image, right? And then down here we have a second phase. And the only reason I'm calling it second phase is just by convention, because we have the build phase above it, and then the actual production kind of resulting image below. And so Docker will start in the top and run down through, and then it gets here and says, oh, okay, you want to build another image, and it's based on the Alpine version of Nginx, right? And now in the copy, we have this new from. So we're going to say copy from, not locally on my machine, but I want you to copy it from build. And it'll look up here at your build image and say, okay, I'm going to use that as my source. So it's going to look in code build inside of this image and take all those files and copy them into user share Nginx HTML. And then by default, Nginx will serve HTML, CSS, images, all that type of stuff from this folder. Then we expose port 80, and then we start up the Nginx server. So the Nginx server is the 1.12 Alpine is very slim. It doesn't have text editors, libraries, things that you don't need to run your basic web server. And so we do everything we need to do to build our React application using our node, a big image, right? And then we say, okay, now just pull out the files and put them in this nice, thin, slim image, and we're going to use that one, right? So you can also do that on Node. So if you're using, let's say, TypeScript or something like that, you can run a build step and transform all your code from regular JavaScript into TypeScript, minify, bundle everything up, slim them down, and then pull those out and run them in a very slim Node image. Okay. So what is Node as build? So this is a multi-stage build. And the way you can do multi-stage builds is in your Docker file, you're able to label images. And you can do that on the from tag. And then later on, as you label them, you're able to reference them later with commands. All right? So we labeled this image as build. And then later on down in our Docker file, we're able then reference back to that image and pull files out of it. So that's what we do down here on line 16. So if this copy command just looked like this, then it would look locally in my code build directory inside of the context that I've sent to Docker Engine, and it would look for all those files and copy them into the image. It won't find them in this case. But since we don't want to pull them out of the context, the Docker context that we're working in, we tell it, oh, hey, pull it from this image that I built above it, labeled as build. So that's the from. That's why we label it as build. And the build is, this term build is nothing special. So this could be my infamous foobar, right? So you can label these as whatever you want. So this could be foobar, okay? The build, sometimes there's the build, you know, when we have terms that are overloaded with meaning, sometimes it gets a little confusing. So like exactly down here, we're running build. This build here on line 11 and this build are different. So I've seen a lot of very complex Docker files that will have a build phase. It'll have a testing phase, and then it'll have a production phase. Yeah, let's call them phases inside of that Docker file, and you can run each one of those in succession, or you can tell it, you can put a build target. So if we only if we targeted just the build, this label, when we did a Docker build, then it would only build that image and anything that it depended on. So it builds a dependency graph. So if this was, let's just call it prod, and I did a Docker build and said target prod, Docker engine would look at it, the build engine would look at it and say, okay, you're targeting this, and it would build a dependency graph and say, okay, well, you're building from build, and so it will also build this image, right? If we had another stage in here that build was not dependent on and prod was not dependent on, that stage would not get built when we target prod. Cool. All right. So that's multi-stage builds. They're a great way to build. You use a image that has all the tools that you need in it to build your application, and then you can use a very slim base image and just pull those files out and put them in there. And then this build image goes away, and you just have the resulting prod image. Let's call it. Awesome. Another thing you want to think about in your especially with Node, is you want to gracefully shut down your server. You know, it's a Node. A lot of processes that are running with Node are you know, REST APIs in general. There's server processes that connections are made to, and those connections can hang around for a while. And so when you when either your runtime like Kubernetes or Swarm stops that process, if you're not listening for the sig term, the signal to terminate your process, called a sig term, then your process just kind of hangs there, and then usually the runtime will give it depends, but it'll give it 10 seconds, right? And then it just kills your process. So really what you want to do with Node is you want to listen for that sig term, and then you want to kind of stop taking requests, and you want to kind of flush out the rest of your requests that are already there. Let them finish, and then gracefully shut down. So let's say you're building an e-commerce application, and your little Node process is the checkout process, right? And someone starts checking out, and for whatever reason, the orchestrator or just the operator kills that process, kills that container. But you have connections to it, and they're trying to purchase things, right? You don't want to just end those purchases, right? Just kill that process for that user, and you know, he gets a 404 or 500 error, and then hits refresh, and he ends up on a different server, and things are missing and can get in a weird state, right? So what you want to do is listen for that sig term. You want to stop taking incoming connections, and then you want to drain the rest of the connections that you have. So let them complete, let your end user finish their checkout process, and then finish that, then shut down the server gracefully. There's a couple different NPM packages that do that. I don't have one particular that I'm going to recommend, but I'll show you real briefly. I don't know if you guys are interested, but let's see where we're at. We'll take a little look behind the scenes. So I'm going to go to my core. So if you guys been watching and follow my demos, I use this framework called Ronin. It's something I built. It's not You can use it in production. I have, but it's really meant for. It's an easy way for me to demo. It sits on top of a lot of boilerplate Node.js code that you write a lot. So I use Ronin Server. The kitchen sink is kind of my playground here. So let's pull one of these up. So you can see I'm using the Ronin Server. I create my server here. And then you'll see I'm not really listening for the sig term. But what I do down here in the Ronin Server library, if we pull that up, you'll see right here that, sorry for fast scrolling, folks, but you can see it sits right on. I just wrap Express, do some more interesting stuff, but set up ports and all that good stuff. I set up listeners. Let me just scroll down. If you're interested, this is up on GitHub. Feel free to go check it out and fork it and submit PRs. I would love to improve this. So I have since these are usually demos that I use Ronin with, I don't necessarily need to drain requests and those type of things. So you'll see here that I'm listening to sig int and the sig term. And then I call shutdown. Then I tell it what signal's been called. And then basically I just drop a message and then I exit the process. But inside of here, using Express, you can it's a little complicated. Maybe I'm opening a can of worms here that I didn't want to do. But anyways, you basically have to count up all the connections that happen to Express, kind of keep track of them, and then close them out as they're being returned. And then when you get a shutdown, you look kind of in your stack and go, oh, I have requests. Let those finish, and let me check every once in a while. Okay, don't accept new requests, but let these requests finish, and then I'm okay to shut down. I think I actually have it at the top here. Take a look at stoppable. That's a pretty decent one. Okay, cool. So again, just to recap, you wanna think smartly about how you shut down your containers, right? You just don't. If you're running a web service that you have connections to that could be important, you just don't want to shut down your process. Just kill it, because they might be doing interesting stuff like purchasing things for your company. Okay, one of the big mistakes I see folks do, especially with Node, is let's look in here. Is that a lot of folks use npm, they use or yarn, right? And they have all these scripts inside of their package, JSON. Here we just have one in the server, and basically, so I can do an npm start, and that just calls node server.js, right? And so what I see a lot of folks doing is in their Docker file. This is the front end. Let's look at the server Docker file. So a lot of folks will do npm run start, right? So they're recreating that npm command that they usually do, when they're developing locally. We usually do npm start, right? We're so used to just typing that out, npm run start. But inside your Docker file, you don't want to do that. What happens is npm will be the first process, and then it'll spawn node as a second process. And now you have two main processes basically running inside of your Docker, inside of your image. And we don't want to do that. Just use node. Don't use process monitors like nodemon and what PS2 I think it is, and those type of things. Let your orchestrator, so Kubernetes, Swarm, whatever you're using as an orchestrator, let that process manage your container's lifetime. Right? So let it start and stop those containers. If your process dies inside of that container, so node, let's say you have an unhandled exception, it just blows away your process. Let it die and let the orchestrator start up a new one, right? And then you'll see it die again, start up a new one, see it die again, and then that's when you know you have a problem. If you had a process manager, your container would start up, npm would start. Let's say you're using nodemon, so let's change this to nodemon, and just know that I have it there in my dependencies, right? You can find it. So if npm starts, then it starts nodemon, and then nodemon starts node and is watching that node process. And when the node process dies, it starts it again. To the outside world, your container looks like it's just running normal. It's just running, right? And it never dies. And so then you're gonna go and look at the logs, make sure everything's running right. So as a best practice, don't do that. Just start node directly within your Docker file. And if that process dies, let your orchestrator start a new image for it. Okay. Yeah, so no process monitors inside of your image. Only start one process. Don't use npm to start node inside of it. Just use node. It's totally fine. The UI, I won't look at the UI because, again, we're not running this on the server. We're running Nginx, right? And you can see we run Nginx as the command here. So if that Nginx web server dies, another one will start it back up. What about using Docker Compose to restart the process? Yes, you can do that. There's restarts and those type of things in Compose. You can use that. And it depends on what orchestrator you're using. If you're using Swarm, it can use that. Yes, you can override the command using Docker Compose. Yeah, sorry. I'm not sure if I want to go down too far into what an entry point and command is, the differences between the two. But yeah, so basically your entry point is the process that'll be the default entry point in that image. And then you can override that, and then in command kind of gets passed into the entry point if you have both. And then when you do a Docker run, you can also pass in a command that will overwrite the command that's in your Docker file. You'll see a lot of the official images will use an entry point script that handles some of those different things. So if you don't pass in a command, it will use the default command. Some of the databases are really good to go look at the official images, to go look at their Docker files. And that's actually, let me show that here. Where's my mouse? So if we come in the hub and let's just take a look at, now let's look at this one here, 12.18.4. So if you actually click on those links in Hub, it'll take you into GitHub, and you can actually see the Docker file that's used to build that image, right? Which is great. So you can go, if you're like, oh, well, how was this image built? What's inside of it? Those type of things. You can go and look at the Docker file that's actually built that image and read down through it. Let's see. So here's kind of what I'm talking about. So it provides an entry point for you, and the default command is node. But since in our let's come over here, it's a little bit simpler. Close that down a little bit. Since in our Docker file we set up a command, this command here, and you can see it's just basic node, will be overridden, right? It will execute it'll pass in node and server into the entry point script, so docker entry point.sh. So we can actually go look at that. So I just went up one folder here. So we were looking at the Docker file. Now you can come in and see the docker-entry point.sh, and this is the script that actually gets run, right? And there's a bunch of bash stuffs in there. It's basically looking for, did you pass anything in, or is the command node? If it's not, just use node. If it's not, use whatever was passed in. If it wasn't passed in, just use node. Someone correct me if I'm wrong, man. My bash is off. I haven't written bash scripts in a long time. Okay, cool. Let's see what I have. We're almost at time. Feel free to dump any questions in. Let me scroll up the chat a little bit. Okay, awesome. Just looking through my notes, see if I hit all the major points that I wanted to hit. Yeah, those are pretty much talked about all of the kind of fundamental best practices that you want to go through when you're writing your Docker files. And again, you also want to think about it the same way as you think of optimizing your code, right? When you're first writing your code, you want to get it to work, right? Let me just get it working. And then you want to go back and look for speed optimizations, unwinding for loops and those type of stuffs, right? Nowadays, our runtimes are very, very good at optimizing your code. Even the JavaScript engines, right? V8 and those engines are really good at optimizing your code. They'll run them really fast, right? So as humans, we don't do that great of a job of optimizing it. So you want to do that. You want to save that to the very, very end, right? So you might read some code and it might look like, ugh, this is going to be slow. But actually, when you run it, it's fast enough, right? And that opens a whole nother question of what is fast and what is slow. To be honest, it's relative to what you're trying to do, right? So if you're, most things don't need to be lightning fast, right? So usually straight, readable, from top to bottom, well-structured code with, loosely coupled, highly cohesive code runs fast, right? And same thing with your Docker files. You don't want to early optimize, right? So start out with an image that you know has all the tools and libraries in it that you need to get your application running. Once you have your application running, then look at, okay, well, maybe I should look at the base image that I'm using. Maybe we should build our own base image, right? And only put the tools in there that we know have been scanned for vulnerabilities, those type of things. And then everybody uses that base image. And another team can manage that base image, make sure it stays up to date, make sure it's scanned for security vulnerabilities, those type of things. And then you can build your image on top of it. And in that case, too, you can have one for production. So a very slimmed down, corporate name node base image that your company built and is the base production node image that everybody uses. And then you can also have a node image that your company built that has all the tools in it to build your applications. And same for other languages like Go, Java and Python, all those. So don't early optimize, get everything working. If you're trying to optimize and you're using a base image and you're fighting an error and you can't figure out why, right? You want to remove all the variabilities as much as possible and only try and focus on what exactly the error is. I've done this from experience, right? I thought I'd get fancy, get a nice thin base image. And then when I try to build my app, it's not working. And I'd spend hours trying to debug why NPM is not building things correctly for me. And it turned out to be the base image. So start out with the base image that you know is good, thick, has all of your tools in it you need. Build your image, get it working, and then go back and optimize for size. And then make sure you have, you think about caching when you build. If you're building your images a lot, caching really helps because you're going to move those files that change the most all the way to the bottom. So your cache does not get invalidated. And it'll speed up your builds. Use BuildKit. You can read about BuildKit on our website. It's called Buildx is the CLI. But you can read about all things BuildKit here. That has nice caching, image caching, those type of things. You can give it, you could tell it to use an SSH agent if you need to, go out, let's say, to get and pull down a repo in your build process, and you need to use SSH. Instead of copying in your SSH keys into the image, you can use SSH command. You can use secrets that way also. It'll set up temp file system and include your secret inside the image for when you're building, and then that temp will go away. Different things like that. So you'd enable BuildKit and Buildx. It'll speed up your builds tremendously. Awesome. Yeah, it's not necessary to use Teeny anymore. I don't use it for any of my. It won't hurt, but you can use it. You can still use it. It'll pass on those sig int and sig terms into your node process. But Docker has that built in now. You don't necessarily need it. Node will receive, if it's the process one, it'll receive your sig int and sig terms. Yes, James, you can use Buildx for multi-architect builds, and it has a whole bunch of other stuff. So even if you're not doing multi-architectural builds, I would say still use Buildx. It just will speed up your builds with caching. There's just and it can parallel process things. So if you have a multi-stage build, what Buildx is, builds that dependency tree, right? So it'll look at, okay, I have two froms in my build, in my Docker file, excuse me. One goes off and grabs some dependencies and builds those. Another goes off and grabs some dependencies and builds those. And then my third from depends on both of those. So what Buildx will do, or BuildKit will do, is look at it. We'll build a dependency tree and see I have from A and from B, which aren't depending on each other, but from C depends on both. So it won't run build C first. It'll run build A and build B together in parallel. And then once those finish, it'll run build C. If you look at, let's see if I can do this. It's going to go into, there's actually a really good DockerCon video that one of our Docker captains gave that explains just that. Let's see, build. Let me turn the volume off. Okay, pause it. So go watch this video. It's a great video. Explains everything around multi-stage builds, around build caching, remote caches, using an image as your cache, all those different things. So it's a really great talk. It goes fast, but it's a great starting point to then jump off and get more information. Yeah, I think we're about done. I appreciate everybody joining me and watching me. Again, a quick reminder, next week will be on Thursday. Chad will be back, and then we'll be doing Thursdays every week after that. Please feel free to tweet at me for anything that you want us to see, anything you want us to see, you want us to talk about, any kind of demos, those type of things. Feel free to, probably the best way is just to tweet at me or Chad. And yeah, thanks again. I really appreciate everybody, and everybody enjoy the rest of their week. Take care.